Okay, Hikma, but I didn't. Where did you try to chat me up? I didn't see a chat from you. Hikma, you can unmute. Let's talk.
Good evening, sir.
Yeah, good evening, Hikma.
It was on Discord.
Oh, Discord. Was it a direct message or?
It was a direct message.
Oh, okay. Um, I'm checking that right now. Yeah. Hikma, just remind me at the end of the class today. Then, Zainab, why didn't you fill the attendance? Because the link was dropped during the meet, so I don't know why you didn't fill it. It's only Hikma I know about. She told me she had some things to go do during the late hours, so I only recognized that Hikma took permission to leave the call. So, Zainab, what happened, Zainab? You can unmute. Let's talk.
Good evening, sir.
Yeah, good evening, Zainab.
Sir, I did not make it to the end. That's why.
Why didn't you? What happened?
Sir, I have to attend to my customers.
Oh, oh, okay, okay. All right. So, what did we do last week? What did we do, Zainab? Let me be sure at least you stayed up to some point. What's going on? Why is everyone didn't fill the attendance? Why? For checking for the link. I catch you would have joined the call again now. It's not the meet link is not something you have to be let in before you can just join the call and check for the link. But Zainab, are you there? Zainab, are you there? Hello, Zainab. Because the only way I can let you fill up for last week is if you can just briefly tell me what we did last week. Then I'll be sure you were here until, like you mentioned, you had to go. Alex, hi. You want to say something?
Yes. Okay. I just wanted to say that this link that you're talking about, has it been
Mm-hmm.
going on? Because I've been on, like, just last week that I was off. I didn't go. I didn't attend the meeting, but I've been attending other meetings, and then I've not been feeling any link. I thought people were just snapping the names on the meeting.
No, no, that happened just that what's it called?
Upper last week.
On Yes, that was just upper last week when I couldn't get hold of the attendance link. So I had to do it that way, yeah. So that
Wow.
the effort of everyone in the meeting doesn't just go like that. And that have been handled. The screenshot of everyone on that meeting have been backfilled, if that's the correct word.
Okay, that means like I've not been feeling any link, but I've always
All right,
been on
so
the meeting. Just
okay, no problem. So now you know every time you're on the meet, at the end of the meet, always look out for a link to fill for attendance, please.
okay, okay, okay. Thank you.
All right, Mopelola, hi.
Hi, good evening, sir.
Yes, good
I think
evening,
I'm
welcome.
having the same issue with Alex
You're
because
having what?
I've not been signing the attendance list. The thing is,
Okay.
I used to attend to something by 7 o'clock, and I don't used
Mm.
to end the meeting with the class. So I don't know.
Oh, that's unfortunate. That 7 o'clock, is it every Saturday you have to go?
Yes, sir.
Okay, okay. Although today, we've already used up to 16 minutes. I was hoping to finish before 7. But it's fine. It's fine. And thank you for speaking up. We'll get that sorted out, Mupelola. Okay.
Okay, sir. Thank you, sir.
All right. So let's get started. But there are a few chats. I don't know. We should address. Let's get started. We are behind time. Samuel, please make it briefly. Hi. Just make it briefly so that we can get started. You're raising your hand.
Okay. Okay, yes,
Mm.
thank you. I just wanted to ask, what is the fate of those that have missed other meetings? We're supposed to meet a certain percentage. Like,
Mm-hmm.
would that be counted as lost, or as would those meetings be counted as missed for us? Like, what is our fate? Because I've not missed any,
Mm-hmm.
apart from the very first one, whereby there was no actual
moderator from data camp, whereby we had to sort it ourselves. That was the only meeting I did not complete, but I have attended every other meeting. I think I only filled a link once. So what is our fate for those other meetings, sir?
You mean there's a meeting where there was no TA on the call? Is that
Yes,
what
that
you
was the
mean?
very first one. We
Okay.
took charge ourselves, we introduced ourselves and
Okay.
just made introductions and our
Okay.
expectations for the course. That was the very
Oh,
first
okay.
one, actually, yes.
Okay.
But
Mm,
since then there have been, I think, TAs on all of the courses, but
mm,
it was only in one of those that
mm,
the meeting link was shared that I filled. The other ones, none was shared.
mm.
So I'm asking Faith for those ones because in the on I think the onboarding meeting, the very first one, we were told that
Yes.
after a certain amount of months that
Yes.
if we've not met a certain percentage of meetings attended, that
Mm.
the scholarship might be terminated. So I just want to know what would happen for those meetings whereby we did not fill forms, but we were in attendance.
Well, I'll get to discuss this with the team lead and the other TAs. We'll just have to look at the statistics of classes that have been held so far and where meeting links were omitted,
Okay,
and
sir.
we'll know what to do from there.
Okay,
But
sir.
outside the other one where there was no TA, just leave that one aside. For everyone there were TAs, we'll have to look at the statistics like I just mentioned, and we'll
Okay, all
definitely
right.
know how to go about it.
Okay, thank you, sir.
Yes.
Yes,
All
sir.
right, everyone. Let's get started, please. We are already behind time. 7 o'clock was supposed to be the goal for today, the goal of our meeting adjournment, but let's see where fate takes us. All right, welcome everyone once again. And the slide is also telling you welcome. So we'll just be brushing over XGBoost, and if time permits us, we'll go as far as we can. I know most of us might have already done this, but it's still okay if we go through this together and we share ideas, because there's something Alex understands that I don't, and there's something Richard understood and I didn't get. So we'll have to share ideas, join heads, and see what we can get through. But let me see, give me a thumb up if you've come across, you've done something on XGBoost before. Okay, so nobody have done XGBoost. Nobody. Okay, DG, you've done XGBoost, right?
Yes, I have. Yes, I have.
All right, that means it's only DG, Hikma. Okay. It seems all right. Alex have done XGBoost. Anyone? Okay, Samuel, thank you. Okay. It looks like it's just a few of us. All right. So let's get started. But before we get to XGBoost, I believe for fundamentals. Okay, Samiat, I see you. For fundamentals, these are concepts you should have before we get to XGBoost. Concepts such as supervised learning, particularly classification in supervised learning. Decision trees, you must have known about decision trees and boosting. But regardless, we can brush through supervised learning, quick revision. It relies on labeled data, if we remember correctly. Um, okay, yes, there should be some understanding of past behavior in the data sets which you're using to train the model. An example of supervised learning is image recognition. Yes, like, does a specific image contains a person's face? Yes or no? using labels 1 or 0. 1 can stand for yes or 0. So you're training this data on vectors of pixel values. Now for images, these data points, or that's how the pixels are calculated from an image data set. I believe that should refer to data points. They are represented as pixels. An image is always represented in pixels. So whenever you come across an image, just is slight sidetrack into this concept. Whenever you come across an image of yourself in particular, under hood, the subunit or the end unit of what you see on your screen are pixels. So the computer have to see them as pixels, not really what you're seeing, before it can interpret it. Then supervised learning classification. The outcome, yes, the outcome we tend to work with or predict or classify can be binary or multi-class. That is, you can have a case of just two situations to classify or more than two. And okay, an example of binary classification is will a person purchase an insurance package giving some quotes, like after giving a quote on about the insurance or some other thing related to insurance, will this person you've shown this quote to buy a package? The answer there is yes or no, right? Or we will buy or will not buy the package. So that binary two situation in this case, like I explained, we know all this. It's just, or we should know all this. It's just revision. The multi-class classification example is where you're classifying the situation where you classify, for instance, the species of a given bird. So from this image, you can see different birds with various colors. I can see orange here. I can see different. I'm not really familiar with colors, so please permit me. So you can be given a situation where, okay, you have the bird, and we don't know what bird, but we have a model which have been trained on various species of bird, and we have a new data set of birds. So we might want to know which of this color, if color tends to represent different species, like which of these species those birds in the due data set would represent. We should also know this. One of the metrics, there's some other metrics for calculating classification models and binary classification models in particular. AUC is one. That's a metric. Then some other metrics for evaluating a classification model are accuracy score or confusion matrix. We should know all these. It's a review, it's a revision. And other supervised learning considerations. Okay, yes, we should know this as well. Features can be either numeric or categorical. Yes, that's very basic. Numeric features should be scaled, Z-score. Yes, Z-score has a relationship with standard scaling. They are quite similar. Like when you scale a data set or a column, for instance, what you're actually doing is you're getting the Z-score of each data point in that particular column. That's what is going on under the hood. And categorical features should be encoded. Yes, this is basic. Not just one hot. It could be one hot. It could be some other forms of encoding. There are various types. Then this is an application of supervised learning. You can use it in ranking. You can see Google use it already. Google use this approach. There's recommendation. You can use what's it called? You can use supervised learning. You can apply supervised learning classification for recommendation. Yes, recommending an item to a user based on consumption history and profile. Example, Netflix. I explained this during one session. I can't remember where we touched this, but I think we talked about it. But anyways, there are so many approaches and recommendation can be done to build a recommendation engine. Yes, so okay, yeah, clustering. You can use clustering approach depending if the data has some labeled data sets. Now for this case, okay, let's sidetrack for a little while. Who can tell us how we can use supervised learning to handle a recommendation task, just like this in Netflix? I treated this using clustering, but who can give it a try? Please, quick one so that we are right on time. 7 o'clock is our target, hopefully. Anyone, raise your hand. Anyone want to try, please? Okay, nobody. Let me quickly touch it. Based on consumption history and profile, yes. So this could be the details of the available data set you have in order to build this recommendation engine. You have how the users in particular have been consuming the platform, what kind of contents they normally go through, and their profile. Yes, their profile code. Okay, Tato. Thank you very much, Tato. Please go ahead, Tato. It's been a
Oh,
while.
always, I wanted to say also in music platforms.
Okay, yes. You mean application of supervised learning, right?
Yes.
Yes. You're right. Spotify, yes. Spotify, and I use that as an example. All right, thank you, Tato, for that input. So, based off the Netflix example we have here, which also apply to Spotify, as Tato pointed. So, with this history now, we can do it this way. We gather past data from users based on these features, and we tend to predict if from a set of available contents based on their previous consumption, they will likely want to interact with that set of contents we have that is based off their previous consumption. They can also use review. You can check out reviews of people. Let's say there is a review data set for some set of movies, Black Panther, Avengers, John Wick. So based on that, if the reviews from that data set indicates that these people with this particular profile that matches with the new set of people we have to predict on, if they have similar consumption history and profile, and yes, they gave this high review on Black Panther and what's it called, John Wick, the system will automatically suggest or recommend Black Panther to you if you've not seen that. If they check your watch history and they don't see that, they recommend Black Panther to you because you have this similarity with you have a similarity in consumption history and profile to someone who have rated some movies and the likes of that. Please thumbs up if you understand the explanation I've dropped so far. Thumbs on, please, so that we know we're on the right page and we get going. All right, thank you very much. All right, XGBoost. Let's get started. What is XGBoost? Now, but I don't know. I have a feeling we need to talk about decision trees and what's it called? At least decision trees, and since it wasn't revised here, here's that decision tree. It's loading. Okay, decision trees. All right. So let's talk a little bit about decision trees. Does anyone want to try what a decision tree is? Anybody? Tell us what you know about decision tree, what you remember, because I don't just want to get started without that. All right, DG, please go on.
Okay, so decision tree is a kind of classification and regression tree that will mainly splits our data into subdivided because we want to predict or classify something. Is it yes or is it no? Or for the regression trees, we want to use the user decision to know how much rent will cost in the next 3 years or something like that. So decision trees helps to split our data using the features that we have, using the features of our data set. It helps us to split data into questions, either yes or no questions. Does the feature have this? If it does it have this? Yes. Then some data, some components that fit, some features that are fit into that data set will be in that leaf. So we have the root node. From the root node, we ask the first question. So the first question splits our nodes into a further component. So when it gets to the final node, I think that's the leaf node. The leaf node will, be a very homogeneous in nature, given that a particular kind of people in that data set, maybe 5 people belong to US or 2 belongs to no, but it's usually one is usually more than the other. So decision tree just helps us to split our data into final decisions, so we can actually make labels from our data, and we can predict or quantify something.
Okay, that's very good. Please applaud DG. Thank you very much for the explanation. Everyone, please appreciate him. Applaud him. Thank you very much. Thank you, everyone. So, in addition to what DG has explained, which he's definitely on point. I haven't seen a perfect. I can't say. Let me don't say perfect. That sounds extreme. I've not seen a much closer analogy used to describe decision trees than 20 questions. There's a game called 20 questions. Who knows 20 questions? There's a game they play. It's called 20 questions. Nobody. All right. So 20 questions is a kind of game where you get to ask. There's an answer, but before you get to the answer, you have to ask branching questions. So branching questions could be like, okay, maybe what example can I use now? Maybe you want to predict if someone wants to play football, and they start off their question like, it's the weekend, or okay, you be the one to ask the question. The person have in mind that they want to play football, but you don't know what the goal is. Okay, so you can ask, um, is it weekend? Yes or no? If it's yes, if it's no, most people don't play footballs on weekends, so definitely there's no playing of football. Then yes, okay, and you get to ask, is it morning or night? Or okay, yes, day. Is it day or night? If it's night, no, nobody plays football in the night unless it's not football you want to play. You're a suspect. Then you go to the other branch of the question. If yes, it's day. Is it very hot? That is the sun very scorching? If yes, of course, nobody wants to play ball in a very, very hot sun, or is the weather light? It's just something like that. So that's how the algorithm does this split. It looks at your set of features and it asks these questions and splits based off the features you have. So you can look at the feature. There's a feature for age, depending on what the tax is. There's age, there's gender, there's income. It looks and split based on these features before it arrives at the answer or a trained model. Then boosting. Okay, before that, please, hope everyone gets what the explanation is so far. Thumbs up, please. But I still encourage us to check this out much later. All right. Thank you, everyone. Thank you, guys. Okay. That's fine. Let's move on. But I encourage us to still revise, even if it's been a long time you touched it. Still go on and check decision trees. A very simple algorithm to check out. So boosting. All right. So boosting is an ensemble method. And from the word ensemble, it means you're bringing one or two things together. So that means you have more than one trees coming together to achieve the result. But boosting is a situation where you bring base learners. Okay, I've already touched the word. Now, base learners refer to a single tree. And in most cases, this base learner refers to a weak model, like a weak decision tree model. So in this situation now, boosting, you have weak models which are learning from each other. So you start off the training with a single model or a base learner, which I've explained to be a weak model. So this model is trained on certain features, not all, and from that training, the next model that is trained learns from the mistakes of the first model or the previous model. So what it tends to do is it wants to correct the mistakes or inaccuracy or whatever metric that is lagging on the previous model, and that's how it goes on until it arrives to a perfect or a better um, prediction or model. So I believe that's just a quick revision we should know about that before we get started on XGBoost. All right, we are back to base. Now, XGBoost is an optimized gradient boosting machine learning library, rather. So you can see the word here, boosting. There are so many types of boosting libraries or boosting approach. There is ADA boost, there is advanced, yeah, that should be advanced boosting, yes. And there's XG boost. I think there's some other kinds of boosting approach. And XG boost here, this X stands for extreme and G means gradient. So extreme gradient boosting, yes. So it's an optimized gradient boost machine learning library, and it was originally written in C++. C++ is a programming language, so it was used to build this package. In fact, I can't count how many Python packages that have been built by the C++ community. Shout out to them, they are really doing well. And it has APIs in several languages. Yes. So apart from Python having access to the use of XGBoost, someone writing in an R developer can be able to use XGBoost. Someone writing in Scala, Julia, and Java can also use XGBoost. But here we are, Python developers. So yeah, we are part of this advancement or use. What makes XGBoost so popular? And yes, XGBoost is actually popular. It is popular. It's as popular as it gets, because the last time I checked, there's this graph of the most used algorithms or quick to go algorithms. Although we know there are certain situations where some algorithms should be should be choosing over the other, but default quick to use algorithms XGBoost. I think that was even the first as of, is it 2000, and this is 2005. Can't remember when exactly I checked that graph, but that should be between 2024 or 23. Yes, XGBoost was one of the most commonly used algorithm, and one of the reasons is it has speed and performance. Yes, it has speed and performance. The core algorithm is parallelizable. Yes. Now, this actually adds up to this. It adds up to this statement that it has speed and performance. Now, what this parallelizable means is that for a situation where you're to do bagging, there is also an approach in ensemble methods. There are two types of ensemble methods. I didn't touch it, or too common. I don't know if there are new breakthroughs in that assembly method, but the two commons are boosting, which I just mentioned earlier, and there's bagging. Now, what bagging does is it runs these base learners. For boosting, base learners are run sequentially, in the sense that one model has to finish before the next one learns from the previous one, learns from the weakness of the previous base learner. But for bagging, the base learners have to run sequentially. Sorry, they have to run in a parallelized manner. So that means as one base learner kicks off, the other is already, or the rest of the other base learners are kickstarting. So they tend to be trained on the available data set, and the average of these base learners is choosing as our final point to make the prediction. Yes, an average is taken. So now, for that bagging situation, now XGBoost is built in a way that this situation is run in a parallelized manner without waiting for one base learner to wait for the other. So this is time management we are talking about. So instead of the model to compute things sequentially, it just does its stuff. And I don't know if we are we familiar with the word asynchronous? Please, who knows about asynchronous programming? Anyone? Asynchronous programming. Okay. So asynchronous programming is a kind. Okay, Tochuku, thank you. All right, asynchronous programming is a kind of programming approach where things are not, or execution of codes or concepts or services are not done with the dependence on the whole system. Like it's not waiting, it's not a blocking approach in the sense that okay, it has to run line by line. That if you get to say okay, there's a service for sending an email. Let's say you have for software engineering, you have a service where you have to send an email to someone, and following that, you have to how do we do it? Okay, run a data manipulation task, for instance. So asynchronous programming makes sure that while email is being sent, you can as well be running data manipulation tasks. So it's not blocking. So if it was to be blocking, which is synchronous, email needs to be sent first. Until email is sent completely, you can't go ahead to do data manipulation, or the system owns carry out data manipulation. And you can see that in website. I don't know if you've been through a website before where you have to do some tasks. Let's say you're supposed to fill a form and click a button, and sometimes until that button have been executed, you can't do any other thing. That's synchronous approach they use here. But if it was to be synchronous, even if the button or whatever task is to be executed via that button click, other tasks, you can still go ahead to do other tasks. Tochuku, you raised your hand. I don't know if you wanted to say something.
Yes, I was saying that I wanted to say that the example of a restaurant system is more understandable. I don't know, like
The example was
the example of a restaurant system is more understandable.
okay. You want to give a different analogy, right?
Yes, I don't know if you could just use the example of the restaurant system so that they understand. I don't know.
Okay, to explain the asynchronous approach, right?
Yes, sir. Yes.
Okay, if you have an idea about it, you can go ahead to share now. Let's hear from you. Remember, it's a class where we share ideas.
Okay, I would say for asynchronous programming is like, actually asynchronous programming is like when it's like a restaurant system where I can actually order food. When many people order food, and while their food is being ordered, the food is also being cooked. So the process of not doing one task at a time, like I first of all need to take the order of one person, then I cook it, then I serve the person before actually taking the order of the second person. That process is synchronous. So asynchronous is actually doing many things at the same time, but not all of them will be done. Not all of them will finish at the same time. So you're actually doing many processes. Like I'm ordering food at the same time, I'm also cooking. There's something that's been done in the background.
Okay. That's good. That's very fair. Yes. Thank you very much, Tutuku, for that addition. I appreciate. So, I think I realized his background was a bit noisy, but let me just talk more on what he mentioned using the restaurant system. So he says, in a restaurant, if you walk into a restaurant and you order for a food, while the food is being ordered, there are still other background processes that can be done, and the food ordered, even if it's yet to be fulfilled, other processes such as cooking is still ongoing. And even if we can use the same person, like you in particular, who ordered the food, maybe you ordered for depending on what is your favorite dish, you order the favorite dish in the restaurant, and meantime maybe the food is not ready. You can as well just say, okay, I can take a bottle of water. You can order for a bottle of water. So you can see both tasks are not blocking each other. So we can't just wait for the other food, which was maybe spaghetti bolognese, is yet to be fulfilled. You can as well take water, something like that. So thank you very much, Tochuku. Please applaud him for that addition. All right, thank you, Thato. Thank you, everyone. All right. And now another reason it's popular, XGBoost is popular, is that it's consistently outperforms single algorithm methods. Now, This ensembling approach where you have to add more than one models, yes, more than one base learners is what this line talks about. Like, it's instead of having a single algorithm method, XGBoost does it does a combination of base learners, so that makes it popular in use because the outcome is it's it's on track. Then state of the art performance in many machine learning tasks. Yes, so that means it does well. Then using XGBoost, a very quick example. Let me see if I can zoom this inside a little bit. All right. So there are so many ways we can work with XGBoost. Now, this XGBoost is actually the core XGBoost, what's it called? XGBoost community or package. There's still another approach you can access XGBoost. You can do this via scikit-learn. Yes, scikit-learn has access to XGBoost, but in this case we are using the core XGBoost, the core XGBoost package. Now, to work with XGBoost, you have to first import, of course, you import all the libraries or packages you have to work with, and from sklearn you import the train test splits for splitting data sets. Then this is available class data, and in this case you read CSV. Like, from the CSV format, you read into a data frame, and yes, you extract the X data set. So to do this, you slice for all the features or the columns, except that's what this thing is doing, this particular highlighted point. So you slice for all features or columns on this data set except the last one, which is presumably in this case, yes, it is the target variable that has to belong to the Y data frame or data set. So for the Y, you can see only yes, if you look this particular point now, only the last feature is imputed. So that outputs the, what's it called, the Y or the target variable that will be used to train the model. So we then go on to split using train test split, and yes, you do this. We should be familiar with this process, and yes, you do this imputing the X and the Y extraction we have from our initial data sets. We include a test size of 0.2, so that means 20% of these data sets should be set aside for testing. Yes, for testing. Then you impute a random state of 1, 2, 3. I don't know who asked the question last week. So this can be any vid value, but you have to maintain whatever value is used, even in production, in order to have a reproducible state of your model, or this split actually. Then we go on to use our classifier. Since this is a classification problem, remember XGBoost has a regressor or a regression what's it called, availability or approach. So apart from this classifier, you can see here we can use a regressor approach depending on what our task is. So in this case, it is a classification problem. So we use the classifier and we pass in an objective. Now this objective refers to how we want to score the model or what approach. Apart from logistic, this binary situation logistic, I think there are other objectives. Let me remember. Apart from logistic, I think there's linear. Yes, there should be linear. Is there? Is it linear? Yeah, but there are still some other objective you can use. So M estimator is another argument. I hope you're familiar with that word argument. If argument actually means this, you can see objective equals to seed equals to number of estimators equals to test size equals to all these arguments. So arguments means those variables you pass into a method. Hope I'm not still going I'm not saying some complex concepts. That is, if we are familiar with our Python. Method means a function available to a class. Yes, Yes. So this XGB, for instance, is a class. This import you're making here, import XGBoost as the XGB is a class. So for every method available or every function that is under this class, it's identified as a method. You understand? So we call this method, the method here is XGB classifier. And for every variable we passed a value to here, that is the argument. So please don't get confused with those mentions. So yes, and number of estimators means number of base learners you want to use. So in this case, we are using 10 base learners, meaning that for this XGB classifier, this XGBoost classifier, we are working with 10 base learners who would be learning from each other sequentially. If you remember the explanation I gave ahead. Then we set a seed to this. Remember what the function of seed is. Then we go ahead to fit our train data set, our train sections. We use X train and Y train to fit the model. Then we go ahead to make prediction on our tests, on our X test. So whatever the outcome is, which is the prediction the model was able to come up with on our X test, we run an accuracy calculation via this highlighting is not, it's not giving me the perfect, so that's okay. All right, so this line is where we make a calculation for what accuracy our model was able to come up with. Remember, we always have to calculate accuracy or whatever metric we want to work with to be sure our model can be trusted during business use. So yes, so we do this by first getting the sum of all correct predictions, and we run that by getting the percentage, like out of the whole white test. You know, white test extraction tells us this is a trained data set. So white test gives us the correct outputs for each X test. But what the model we are doing with the model is we are just getting the prediction of the X test. We want to check, okay, from the prediction of this X test, we already have a Y test, which is the correct predictions for those X test and data sets. So with this X test and data set that we've able to come up with some predictions, is these predictions actually correct? So that's why we are doing these calculations. We are checking out of all these um, outcome, the prediction from the X test. Let's check that to the correct values, which is on Y test. Out of, let's say, from this shape. Now this shape means, okay, out of 100 correct Y test we have here, is it 50 the model was able to come up with? Is it 60 correct? Is it 70 correct? Is it 40 correct? So that's what we have here. So in this case, the model had an accuracy of 78%. So it was able to correctly identify 78% of the correct data sets. So it depends on what use case. There are use case where you have to okay, like the vote of which accuracy you should work with depends on the use case. Like for in a situation like what's it called, a clinical state, like say hospital setting, something that impacts lives more directly, accuracy are always sought out to be higher than this in most cases, so that you don't end up taking chances. So okay, what is a decision tree? Okay, decision tree was actually talked on here. That's great. You can still touch it. But so far, guys, please thumbs up if you're actually flowing. Please give a thumbs up if we are making sense. All right. Thank you, everyone. Thank you. Thank you. It's going smoothly. All right. That's very fine. All right. So visualizing it, I don't think I have to stay much there. We already talked about this. There's a particular place I want us to dwell quite a bit on. So, okay, but this actually validates all we've explained and input from everyone on the call, some of us on the call, actually, like DG and some others. So this is a situation now. You can see a question is asked here. Road tested. I believe, let me see. Okay, I believe this should be a situation of the house from this mileage. Yes, I think this should be a situation of buying a house or something. So now maybe this is a situation where if someone will get buy a house or not. So road tested. So the question is asked: is the road tested? No, don't buy the house. Yes. So if the question is answered that yes, we move down a little bit and ask more questions based on the features available on this data set. So the next feature is mileage. Is the mileage low or mileage? I don't know if I'm getting the correct pronunciation, or it's high. Remember, guys, I told you guys to recommend me to a spelling class, or I think I need a pronunciation class this time around. But permit me if I'm not getting the correct pronunciation. So is the mileage low? Buy the house. If it's high, ask further questions. What's the age of the, I think that should be the house. What's the age of the house? Is it recently built or is old? So you can see how a decision algorithm works. There are so many questions, branching questions. That's why it looks like a tree. They say it looks like a tree. Root node, leaves, these arrows here now tends to branch into leaves and many branches until it ends up with the final answers. So decision trees as yes, base learners. I talked about this. So base learner is the individual. Yes, we already talked about this. Talks about individual learning algorithm in an ensemble algorithm. Yes, we know what an ensemble algorithm is, and it's composed of a series of binary questions, as you can see here. Yes or no questions are binary questions, and predictions happen at the leaves of the tree. Yes, so we can see the leaves of the tree here, where prediction is made at yes or no. Then decision trees and cards. Yes, all these are just revision on what we've talked earlier. Decision trees and cards constructed iteratively, one decision at a time until a stopping criterion is met. Individual decision trees tend to overfit. Yes. So now this is the reason why ensemble methods is a very, very good approach this year. Now, if you're to just use a single decision tree, like just a single decision algorithm and that's it to make a prediction, it tends to overfit because there you have to fight between bias and variance trade-off. Who remember what that concept is? Is a very, very basic or fundamental concept we should know as a machine learning engineer. Very, very important. I would love to dwell a bit here. Who can tell us what that refers to? Okay, Mopelola. What do I do for you? What do I do for you, Mope? Okay. Mope, can you hear me? Let me quickly so that you don't miss out.
Yes, I can hear you, sir.
All right. Just send me a DM. I've dropped my number on the chat so that I
Okay,
can
sir.
send you
Oh,
the link across later on. All right.
okay.
Okay. But if you get to finish what you can check in if the call is still ongoing so that you won't miss out on some interactions. All right, but we'll soon close off anyway. All right. Okay, so the question is bias variance trade-off. Who can summarize what that concept refers to? It's very important. That's why I'm tempted not to just walk past that. I want to be sure we have this at the tips of our hands. And by the end of the call, there are certain things, career advice that I would love to leave with you guys. Just remind me, please, after the call. It's very important I talk about it. All right, Mr. Deji, what do you have for us?
Okay, so bias variance trade-off is like one of the most important things that we look
Yeah.
for, that we look to when we are trying to like evaluate our model if it's underfits the data, if it's overfitting. So for bias, right, we want to have like a model that in the middle it's not too biased and it doesn't have too much of variance. We want to have like a trade-off, both so that our bias is good and our variance is good. So for bias is underfitting, is the model does not really know too much about your data. Maybe the model is too simple. in a sense your your values, your predicted values for regression are way off from the actual values, and your classification model, it's really just predicting by chance. There's no, so the maybe the ROC is like very low. So because of that, because it's very simple, it really doesn't really capture anything from the data. So that's the bias is very high. But bias can be high and then the variance can be low in the sense that okay, for variance is like if the variance of the model is very high, it means that the model is very complex, right? And it's capturing every little thing in the data. Like the features are very like there's no like it does not really know how to tell if it's if it's a training data or the actual data. So because of it, it learns too much from the data that it's trying to replicate even with the noise. So there's nothing separating the noise from it. So in that case, the variance is very high. So we want to have like a case where it's perfectly fitted, right? It's not underfitting or it's not overfitting. So it lies in the middle. So that's what I mean.
Okay. Yes, yes, yes. Thank you very much, DG. Yes, yes, that's actually correct. But there are some points I think you were, how do I put it? Oh, not omitted, but there were some overlapping mentions you made, which I want to touch on. So now, in summary, bias refers to accuracy. We can bring down to accuracy. It talks about how accurate your model could be. The variance talks about how stable your model is when it comes to prediction. And from this chart, we'll see that explanation here from this diagram. So you can see a section here that says low variance, low bias, high variance, high bias, and the rest. Now, this first circle we have here, let me use that to explain the variance and bias. This first circle is a situation where you have low bias and low variance. So what does that mean? The variance here is low because there's a stable set of prediction for each point. It's stable. You can see that they're closely around almost the same section because it's quite stable. Then low bias means the the model is accurate. You know, the accuracy of this circle now is supposed to be at this red point. If you look very well, yes, the red point, the red center there. Let's say you're playing that, and for each that you are throwing, this is the outcome. So this case signifies that you had low bias, meaning your accuracy was quite on point. If it was to be high, it means the accuracy was not really there. Then low variance means the stability of always getting that red point is there. Then high bias in this situation and low variance means you can see low variance, high bias. Low variance now, you can see that the point still tends to be almost clustered around each other or close to each other, meaning there was a stability of where you were actually throwing the dart to. But the high bias means the accuracy was quite off. As you can see, it's not on the red point, it was quite off. But also, only stability was the stability, yes, was quite on point because it's low. Then, if you come to this, hope we know where, okay, we can see my cursor. So now this circle I'm on now, which is low bias and high variance, it means that, okay, the accuracy wasn't actually great. Sorry, the accuracy was quite okay, but there was high variance because now the darts you threw were just almost all over the place. It wasn't stable. Yes, you weren't just stable on where this that was directed to. And high bias, high variance. Everything is just high for each concept. So it means high variance, there's no stability, points were just scattered across a certain region, and the accuracy wasn't quite okay, as you can see here. And this is a very fundamental concept in all machine learning problems. You should always find models that balance between variance and bias so that you don't have a model that underfits or overfits. You understand? Like Deji touched on, which is there's a particular point he talks. So if your model tends to learn everything about the data set you're training on, including the noise, it will overfit. And overfitting is a situation where your model does well during training and it just fails. Your accuracy flies, just goes steep. I think steep means falls very low when it encounters new data sets. And underfit means it doesn't actually learn enough in order to make correct predictions in the future. Now, variance talks about stability. So that's why in order to check out for this, whenever you're done with your model design, you calculate those metrics for the bias and the variance in order to see, and standard deviations in most cases is what is used to calculate the variance of a model. These are basic things, please. So let's actually touch this. If you're forgetting this concept, please go back and check on what bias variance trade-off is. It's very, very important. Now, okay, so this is a situation of high variance, low bias. Yes. So this model, you can see in this situation now, if the model, for instance, now it tends to make almost correct predictions, but it's not actually correct, but it's not stable. So this is a situation of being overfitted. At classification and regression trees, each leaf always contains a revalued score. Yes, 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 yes. So this cat here means classification and regression trees. That's what that abbreviation means. Can later be converted into categories. Okay, I think what is explained here is two categories. Okay, yes, yes, yes. So what is explained here is even if you tend to have a feature, a numeric feature, split is done by converting this question. It converts the at the question level is constant. It converts this value, this numeric feature into a question. So if it's age, for instance, age is a numeric column. So during splitting, the question can be there: is the age greater than 30? Is the age less than 10? So it quite explain how this algorithm works with like for regression problems in particular. And even in classification, in classification, if you have numeric features, how it splits, it's what is explained here. All right. What is boosting? We've already talked about boosting. Boosting overview, or not a specific machine. Okay, yes. So boosting is not actually a specific machine learning algorithm. So please take notes. It's not an algorithm instead. It's only a concept on how the decision tree or the ensemble method is approached. So it's a concept that can be applied to a set of machine learning models, meta algorithm, ensemble meta algorithm used to convert many weak learners into a strong learner. We've explained this. And weak learners and strong learners. Weak learner, machine learning algorithm that is slightly better than chance. Yes. Um, Machine learning algorithm that is slightly better than chance refers to a weak learner. Example, if you have a single decision tree whose prediction is slightly better than 50%, that's a weak learner. Then now boosting converts a collection of these weak learners into a strong learner. We already talked about this. Strong learner, any algorithm that can be tuned to achieve good performance. Okay. So how boosting is accomplished? Iteratively learning a set of weak learners on subsets of the data. We talked about this. This is more like revising on all the things we've talked on. Weighing each week prediction according to each week learner's performance, yes. Combine the weighted predictions to obtain a single weighted prediction. Still, we've talked about this. That is much better than the individual prediction themselves, yes. The assembling helps us provide something that is far off better than a single method. This is still the same concept. An example of boosting example. Okay, yes, yes, yes. To be one, we have so many trees in this situation that learns from the previous person. So when to be one, after to be one have been executed, this the next tree, which is tree two, tends to correct the weakness of this tree one, which we see here. So that's one, depending on the number of estimators you indicate, to actually reach a point where you have a stronger learner that can make correct prediction and you can also trust on. Model evaluation through cross validation rather. Cross validation. This is another fundamental concept we should know as a machine learning method. There are series of fundamentals we should have at the tips of our hands as a machine learning engineer to help you stand out and to help you understand your work process. I hope to also mention a few of them. Let's be sure that we have these fundamentals. So, yes, cross validation. In fact, I'm tempted to ask, what is cross validation? Who can tell us? It's very vital as a machine learning engineer. Who can tell us what cross validation is? Anyone, please? No, not you, Deji. Not you. All right, Samuel. Thank you, Samuel. Go on.
Okay. Cross validation is when the data is split into a certain number of folds. So
Okay.
perhaps maybe the data is split into 5 folds now. So
Mm-hmm.
4 folds would be used for training, while 1 fold would be used for testing. So in cross
Mm-hmm.
validation, it will be run 5 times. So for each of those 5 times, because it is in 5 folds, so for each of
Mm-hmm.
those 5 times,
Mm-hmm.
four different divisions will be used for training, while the last one will be used for testing. So for each of those 5 times, a different one will be used for testing, while the remaining 4 would be used for training.
Okay, yes. You're actually on point. Anyone else wants to add to what Samuel mentioned? Meanwhile, let's applaud Samuel. Appreciate him, please. Mm. Anyone wants to add to Samuel's explanation for cross validation because it's a very, very important concept that we should all know. Okay, Labibat, please
All
go.
right. Good evening. Can
Yeah, good evening.
you guys hear me?
Yes, I can. Please go on.
First of all, what cross validation is actually about is like you are repeatedly dividing the available data set into multiple subsets or folds. Like the data set is divided into a specified number of folds. Then you pass those divided data sets into training and testing. Like in each iteration, one fold is designated as validation or test set, and the many folds are combined to form the training set. In general, just like to evaluate the performance of the model. Hello?
Okay, yes. Are you done, Labibat?
Yes, I'm done.
All right, thank you, Labibat. Please applaud Labibat. Meanwhile, Samiat, you can go on. Hello,
Yeah,
Samiat.
yes, yes. Can you hear me?
Yes, I can. Please
Hello,
go on.
oh yeah, I just wanted to have they said it I will have allowed that we use cross validation to avoid the overfitting and underfitting, thereby just having a generalized kind of model performance and also to be able to maximize the way we use our data, I would say. And it also falls when we have limited data, like to just yeah, to just make good use of of the data we have kind of thing. But what I just remember is that it's all to prevent the overfitting. Yeah.
Yes. That's very, very vital. Thank you very much. Everyone, please appreciate Labibat. That point is a very vital one. That's correct. All right, Deji, you can go on now.
Okay, okay. So cross validation for me, I think there was a need for it for which is cross validation. Cross validation is that in the sense that what we're just lucky in choosing like the best train sets and the best ten sets, like just that particular partition, we're just very lucky. So the results that we are getting is kind of overfitting the model because we are only sure that we tested on a particular kind of training set. But cross-validation came in the sense that, okay, what if we can split our data into multiple partitions? Like, so an observation can be in the test set at some point, it might be in the training set at another point, so that it will make the model generalize better to unseen data because it has tested on various observations, so that it's not really just making the decisions just based on one partition. So every data, can either be in the training set or in the test set at some point. So the number of folds, in case you want to put it into 5, 10 folds. So the outcome of what we get from our data is the aggregation of every of partition. So if you're having 2.5 and one having 2.2 or maybe 2.1, so we find an aggregate. So it's like best estimate of all our partitions that we see how we have like a group of factors. We just predict on just one set and we leave on the other set. So that's validation.
Oh yes, yes, yes. Thank you very much. That's actually correct. That's good. Labiba, you want to say something?
No, sir, it was a mistake.
All right, no problem. So everyone, please appreciate DJ. All right, appreciate DJ. They've all done well, and yes, I don't think I'm left with anything else to say about cross validation. Everyone touched correctly on what cross validation is, and yes, we should always know the reason why. Because I appreciate everyone to always approach each concept and learning as how do I put it? Like when you tend to come across certain concept, like let's say cross validation in this sense, like always try to figure out what problem it's solving. You understand? What it does under the hood gives you more weight as a data scientist, or yes, as a machine learning engineer as well, because this is one of those concepts that you should know as a data scientist before progressing into a machine learning engineer. And with this idea now, you can know, okay, why cross validation? Why don't I just stick to train test split? Like, what's all this stress for? You understand? All this new concept. So as Deji touched on the reason why there is a cross validation, apart from what it does under the hood, is it just helps us get more confident series of rigorous training and testing, and you get an average of whatever number of folds you wish to split into. So cross validation is very, very important. Very, very, very important. So please always apply cross validation of on your model approach. So yeah, let's go on. As you mentioned here, correlation robust method of estimating the performance of a model on unseen data. Yes, we talked about that. All the inputs we got so far already talked about this. It generates many non-overlapping train or test splits on training data. So what this non-overlapping means is for every split in its fold, um, features, not all features are used for every split. There's a concept that makes sure that some features are left out from each split. So that's why this non-overlapping was mentioned here. Then it reports the average test set performance across all data splits. Yes, instead of just running it through just a train test split and you get a single performance, we could possibly overfit or underfit, as the case may be. Then cross validation in XGBoost. So this is an example application of cross validation. I believe this is something we must have gone through or used before in the past, like the use of cross validation. And as usual, you import models, you import these libraries to be used, get your churn data, you run a D matrix. So now this D matrix wasn't used the last time. So for XGBoost, not to work with XGBoost, there is this point in XGBoost where the algorithm has to visualize each data point as a matrix. So that's why D matrix is used there. And For some cases, this is even done under the hood. I think for scikit-learn, the last time I researched on scikit-learn, you observe that when you use scikit-learn, you don't have to call the matrix, and that's because scikit-learn have been able to do this for us by default under the hood. So once you just get your data, maybe you cross validate and you want to, do the necessary listening under the hood. Scikit community or library just does this matrix conversion for us. Yes. So then you indicate the features such as okay, this is the params. In order to run a cross validation, yes, which you think it has already been imported, but it's not showing here under the hood. So okay, yes, it's available on the XGBoost community. So you call that cross validation method on XGBoost.cv, and you pass in uh, your churn matrix, which is what you're training data on. You pass your params, which have been initialized here using logistic approach for this classification max depth. For this max depth refers to how deep your tree should grow. When we are looking at that chart, that diagram, you can see so many questions we're asking and it was branching off. And some cases you might not want your branch to be too long or too much. So that's what max depth tends to do. It constrains how large or how deep your a single tree should grow during this approach. Again, guys, this is something we must have known if you've touched on decision trees in the past. But regardless, number of folds is equals to 4. That is the number of folds that should be used for this cross validation. Number of boosting rounds should be equals to 10. The metric approach should be mean error, and these results should be outputted as a pandas, like as what's it called, the data frame actually. Then you calculate the accuracy by minusing 1 from the CV results you get. So that means this model came out with an accuracy of 88%. That's quite good. So this is where we'll close the meeting for today. When should we use XGBoost? It is very, very important. And sometimes I prefer, because if as a machine learning engineer, I think in order to implement something like this properly, these are certain situations we should know. Not just for XGBoost. Like, if you have an algorithm and you decide you want to use an algorithm, I want you to be able to tell yourself, why am I using this algorithm? Why didn't I use the other algorithm? When shouldn't I use this algorithm? These are things that set you apart as a machine learning engineer. So now these are situations where we should use XGBoost. Like, you have a larger number of training samples. This means that you have greater than 1,000 training samples and less than 100 features. This is not a standard actually, but it's telling us that the number of features here should be less than the number of training samples. The number of features should be less than the number of training samples. Let's say, for instance, you have a data set and you discover in this data set, the number of columns we have are too much. It's even more than the samples you have. Let's say you're predicting on if someone will get a house, will buy a house, for instance, and you find out that for this data set, the number of rows you have for the machine to train on is quite small. It's very, very small, far smaller than the number of features you have. That's not a good situation to use XGBoost, because that situation now your data set is highly dimensional, and it's also highly dimensional than the number of rows you have. Does anyone want to say something? Or maybe a question? Okay, let me go. Nobody? I thought someone is trying to unmute to speak. Samiat. Okay, I presume that's a mistake. All right, let's go on. You have another situation where you can use XGBoost is when you have a mixture of categorical and numeric features, or just numeric features. Now the question is, Why can't we just use for a categorical feature like alone when we have a categorical feature alone? Like, why not? Why not? Who wants to give a try to that? Although we are behind, yeah, we are behind time. Okay, let me just quickly touch on that instead of let me don't wait. So now the reason why we can't easily, it's not that we can't use, although there's been an advancement in this XGBoost library. There's been an advancement. The last time I researched, please, I encourage us to always research because there are certain concepts or things we might know. The world of tech is a fast-moving sector, so there are certain situations that keeps getting updated and improved on. All right, so um, before now, confidently, you can't use XGBoost for categorical features. Now, the reason is, categorical features, most cases have to be pre-processed. And one of the pre-processing um, feature or concept that categorical features go through is, what's it called? Encoding. Yes, encoding. And you know what encoding could lead us to, especially when you're doing your dummy variables on it. We talked about this last week. You end up with a lot of features. You end up with a lot of features because new features are created for this encoded categorical variable. Because last, you have to always encode your categorical features in order for the model or the machine to recognize this in a numeric format or structure. Now, when you encode, you find out that you have a lot of features. So for these high features now, you can see that now high features is taking us to this point. This point where you see that the number of features is now less than the number of features is greater than the number of training samples, which is when not to use XGBoost. So that's why we don't easily use XGBoost for categorical. That's only categorical features. Like if you have more of categorical features for your data set, yes, that's one of it. And even if you tend to use encoding patterns that don't create new features, and okay, you just say color, for instance, you use I think that should be a label encoding. Label encoding, which creates, let's say for the same, it doesn't create a new feature, but it just attribute values to those colors. You can okay say 1, 2, 3. You can see that in that situation now there's a problem. Even if you've successfully encoded it using label encoding, the machine will recognize that okay, since red is 1 and blue is 2 and yellow is 3, yellow should be given more importance than the other colors because it has been encoded in an order pattern. So you can see that pre-processing just takes the whole situation to where we shouldn't use XGBoost because at the end of the day, there's a setback when not to use XGBoost. All right. But before I go on, please, does anyone have any question on what I explained for when not to use? Oh, sorry. Yes, for that numeric situation where I was explaining the setback of categorical features. Anybody? No question. Okay, thumbs up, please, if you understand so far. Just thumbs up if you get the explanation. Hakeem, Kesnas, Tafel, thank you. All right, Ibrahim, DG, all right, thank you, everyone. And finally, but I wanted to talk about one advancement, but I still need to validate this. There have been an approach where there's an update on this XGBoost that you can go ahead to use categorical features. Yes. But please make your research, validate this statement because I think I scanned through. I saw that one of my research articles. I saw that there's been an update on that concept. All right. So when not to use XGBoost, it's not advisable to use XGBoost for image recognition, like an image recognition task or a computer vision task or a natural language processing task, which also relates to an understanding problem. And also when the number of training samples is significantly, excuse me, guys, is significantly smaller than the number of features. We've talked about this. So let's just focus on these other concepts like why. Why can't we use for image recognition, computer vision, and NLP, that is natural language processing? Who wants to talk about this? This is where we close off the class for today. Who have an idea? Okay. I'll wait off other hands while DG prepares to answer. I'll wait off other hands. Who else? Who else? Who else? Who else wants to talk? Why can't we use XGBoost for image recognition tasks or computer vision or NLP? All right, DG, it's all yours. Hello, DG.
Yeah, so I'm not sure. I'm just like
Okay.
going off and switch out.
Okay.
Hello, can you hear me?
Yeah, I'm with you.
Okay. I'm not sure, but I'm just going off. I'm not going off. I think that for computer vision, like for example, like you want to maybe capture like the human face. The human face has so many features, like, and each of those features, like they're like billions of pixels, right? Like just our faces alone.
Yeah.
So maybe if you're using XGBoost to capture the face, it's going to capture so many features, like the lining of your eyebrows to your nose down to your chin. So there's like a lot of features to actually capture. So I feel like the features are just so much for XGBoost, and for vision is almost like hand in hand. So just the number of features are just so much.
Okay, so how about NLP? Because that justifies for image recognition and computer vision. Anyone wants to talk about NLP?
Okay, yeah. For NLP,
Okay, go on, Adi. Go on, Deji. Go on.
okay, yeah, for NLP, it's pretty much the same because based on the exercises that we first did about, like a bag of words in like a dictionary. So each of those words have weights for like in a, let me say, like in a word matrix now of maybe over, maybe like in a document has like maybe 15,380 words. I want to know like each of those words, how many times appear in different articles. So like the features are very much, because they're going to have a word, like a word matrix, right? Like each of the weights, how many times do those words appear in a document, right? They will have like, weights. So those weights is like a matrix from maybe 0 to like maybe 10,000. So because you really don't know, because the number of words, each of those words will have like their features. So NLP, right, try to be able to predict maybe how many words appear much or what word is going to appear next. So like the matrix is like so large, and each of those features like to actually maybe predict or maybe classify, it's going to be too much for XGBoost because of the number of features. It shouldn't be more than observations.
All right, everyone, please appreciate Deji. Appreciate him. He has done very, very well. Very well. Yes, yes, yes. Thank you, Deji. Thank you. Yeah, appreciate you. Anyone else, please? You want to go? You want to add something? Just come up, please. We are all here to learn. Please, always just have the idea. Like Deji started off, he said he's just guessing. He's not really sure. He just had the thought. So we are not here to, how do I put it? We are not judges here. Like no one is a judge here. I didn't do law in school, so I'm not a chief judge. No one here is a chief judge as well. So always try to take the flow. At least let's rub minds. You understand? Even if we are incorrect, to correct each other, and that's it. Okay, Samiat. Thank you very much, Samiat. All right, what do you have for us, Samiat?
So the rough idea I have about being able to use exhibits for image recognition will be that we'll not be able to extract pictures, like not be able to extract pictures from the images. And I feel like even if we are going to find a way around it, like okay, how are we going to extract this picture? It's going to be like computationally expensive.
Mm, mm,
However,
mm. Yes, 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 yes. I like that. Especially the last point, computationally expensive. That's actually correct. So, guys, please appreciate Samiat. Thank you very much. Thank you, Samiat. All right. Yes, yes, yes. So both inputs are actually on point. They did very well because most cases, like I don't know if you guys have come across a data set of an image, like a complete image data set, it tends to have so many features. Like the columns are a lot, honestly. And if the columns, for instance, are categorical to start with, you can see that okay, preprocessing will end up giving us a lot of more columns added. So that is just one off experience. And if you want to still go ahead, maybe you're strong headed on using XGBoost, and you encounter what's it called, as Sammy had mentioned, computational expensive process, where there are a lot of features to just split on. And imagine you're running an ensemble method where okay, to build a single base learner for instance, you have to split on so many features before you go on to get the next feature to split on and keep learning. And maybe you have a number of estimator of 10. You can see how the process becomes tedious. Then for natural language processing, apart from DG's inputs, you find out that it's natural language processing tasks. You can find a situation where for a single word, let's say a word now is a feature. Yes, a single word is a feature, and you find that that for English situations, English language situations, a word can mean something in context A and mean something else in context B, and mean something else in context C for a particular document or data set that we are working on. So how does that become a problem for XGBoost? XGBoost, we only see that word and attribute just a single value to it or meaning. So that means we are losing semantic meaning. Yes, that's the word I should use. Semantic meaning. That means the XGBoost algorithm won't be able to know that, okay, this word that you're saying, it should be standardly used like this, could also mean something else in different contexts. So that's the problem with using XGBoost for this set of tasks. So please thumbs up if you understand. You can raise your hand if you still need clarification some on some concepts we've talked about. Only Hikma, that means okay. Ibrahim understands. Okay, just Ibrahim and Hikma. Please raise your hand if you need more explanation. We are here so that we can just touch on it together. All right, thank you, Lapipa, Samia, Tenok. Okay, 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 Thato. Okay, that's great. That's great. That's great. All right. So, all right. We've come to the end of today's class, and hopefully next week we'll be implementing XGBoost. All right. So let me quickly drop the link for attendance. And there's something out. I mentioned that there's something I will need to share with everyone. So while we fill the link, just listing for some things I'll talk on. Let me get the link, please. But meanwhile, if anyone still has a question, please just raise your hand. Okay, is done. Income messages. Okay, Salim said he's sick. Just seeing this message. All right, I've dropped the attendance link. Please, let's kindly fill in. Salim says he's sick. All right. Is Salim on the call?
Yes,
Hello, Salim.
yes, I'm on the call.
Okay. Okay. Congratulations for staying up to this moment. Hope you're getting better.
Yes, I'm getting better.
All right. Well done
Thank you.
for staying
Thank you very much.
patient. Okay. All right. So while we fill the form, let me quickly touch on the few tips I might choose to call it career tips, but this is something I appreciate that we all do. So, all right, I think I noted that down. This is my notes. Okay, so one of the things I urge us to do as while we are practicing or doing our learning curve as a machine learning engineer or scientist, I bid everyone to build in public. Please build in public. Please build in public. It's very, very important because okay, first, let me explain what building in public means. It means, okay, for instance, today we learned about XGBoost, or during your learning, this week you're going to take on XGBoost. For whatever you learn and you understand, you can just go online, your social media, and I recommend LinkedIn and X, but LinkedIn in particular. But you can as well add Twitter, which is X, to it. You can just go on LinkedIn and share what you've learned. You can share by saying, okay, today I learned XGBoost. This is what I learned about XGBoost. Or maybe you did a meeting. Sorry, I said you did a meeting. That's a blunder. You did a project. You carried out the project using XGBoost algorithm. You can go on and say, okay, this is the project I did. This is the problem I solved. Something like that. Now, what's the benefit of doing this now? You tend to build you tend to build momentum in your career, in the sense that, okay, people might be on the lookout. Oh, okay, uh hmm, they can sense that, okay, you're an upcoming machine learning scientist, and at some point you can find that and you see employers reaching out and be like, hey, I want you to be part of my team as a junior machine learning scientist or developer. And sometimes mid-level, depending on how you showcase your expertise in your approach. You understand? So, please, this is off the topic we have today, but it's something I feel that I should talk on. Um, since it's something that could be life changing to, I know situations, I know people, and also I'm also a testifier of this, where I tend to do things in public about my learning curve, and it has played out very well for me, and I'm still practicing it. And as well, go on, mention, okay, today we had a meeting on AI Africa, with AI Africa, on data camp, about data camp, learning platform, stuff like that. You're selling yourself. That's the word I should use. You're selling yourself, and in the future it tends to pay off. Then another thing I want to talk about is yes. Now, this is one learning approach I appreciate that we implement. For every concept you learn, whether an algorithm, whether a concept, or whatever this thing you learn, I appreciate, or I bid everyone to build a project on it. Yes, especially for algorithms. There are lots of algorithms. So under supervised learning now, let's say you learned at the time you learn linear regression. I bid that you build a project on linear regression. Apart from those tasks or exercises you tend to do on what's it called? You tend to do on data camp. I bid that there are places you can get data sets from. Let's say cargo. Yes, cargo. There's cargo. There's I think there's a place called ICO machine learning. Yes, that should be UCI. There's a platform called UCI and cargo. You can always get data set from there, and you implement what's it called? Your linear regression that you've learned. Because self-practice, apart from data camp practices, self-practices tends to, you know, take you from new buy to experience in some way. Yes. Although sometimes real data set tends to be different from the data set you can find on cargo. But cargo is trying. Sometimes they are contributors of real data sets. So this is something I encourage us to do. You learn on linear regression, carry out a self project on linear regression. The next week you learn about logistic regression. Carry out a project on logistic regression. Next week you learn about XGBoost, carry the project on XGBoost, clustering, and that's and so on. Maybe you encounter a new what's it called, a new concept. Go back to those your projects and see if you implemented that concept. Let's say for linear regression, you only did a trend test split and you didn't do cross validation. And today you tend to learn about you've already learned about what's it called, CV, which is cross validation. You can go back to linear regression and check, okay, I didn't use cross validation, let me use it this time around. And that's it. You find out that you grew better with this learning approach, and you end up understand better because now you're interfacing with these things. You're interfacing with these things you only quite maybe just did one test or one practice on the data camp platform. Then finally another thing is research. Like I mentioned earlier, um tech, the world of tech, especially machine learning, is a fast moving, especially a situation for an example is computer vision. This is one of the most, like, the fastest moving uh aspects. And generally machine learning is very fast moving. Like, they tend to be updated research upon research upon research. So I encourage us to always look out for these research articles. There are platforms where you can get these updates, and I think one of it is what's it called, please don't forget, Paul. I think TechCrunch. Yes, that should be TechCrunch. Is it TechCrunch? No, not TechCrunch. If I remember, I will mention it, but we get the idea. If you go on now on Google and check, you can go on Google now and check what are those research and platforms on machine learning I can get updates on, or maybe ask ChatGPT. It will send you link to those platforms. So you subscribe. Some of them have email newsletters. So whenever there's an update, maybe let's say this machine learning framework, the community just updated a few things. You understand? You can get those concepts, or maybe someone discovered a new approach to achieve something which is less computational expensive. You can see this tends to give you an edge over other machine learning scientists or engineers in the market, or in, yes, at any point in time. Because if you interface, let's say you're job hunting and they get to speak with you, um they see how recent you are in the world of machine learning. You understand? They see how based, let me use that word, how based you are. So these are the three things I feel I should just encourage us to practice as a machine learning engineer. So that's the end of the class today, guys, and I appreciate everyone for being part. If you have any question, you can ask now or forever remain silent. All right, any question? All right, no question, no question, no question. Okay. Good night, guys. Have a great weekend. Then, Mr. Deji. Mr. Deji here.
I'm here, sir.
Okay, yes.
Hello, sir.
There's something I want to do by 8 o'clock. There's a question you were asking on, and I hope we were supposed to discuss that on Discord. What's that your question again? Last week, there's something you talked about vectorizer.
Yes, yes. NM and I think NMF and C.
LMF and what? Sorry.
NMF and TFDIF vectorizer. I don't know I don't know what his name. I'm looking for. I don't know what his name. It's like a vectorizer.
Okay, so okay, yes. They have, yes, the vectorizer. But not the. My question is, you said you encountered this when you were trying to handle some things, like you were doing. I think that was K-means. You were doing a K-means clustering, and you encountered, like, where was it applied that you didn't understand? How was it applied?
Okay.
Because that's how I want to
Okay,
answer the
no.
question.
It was a specific. It was specific module on its own. After we did K-means and we did I think we did CT snit too. Yeah, we did K-means. We did hierarchical clustering. So the final two was those NMF. They said it's another kind of unsupervised learning that can be used for, words instead. So you can maybe group words by the order of how many they are in a sentence. Just grouping articles based by subject matters. They use that in clustering. So I I kind of like struggled with it, but I was able to get the initial input. But going further to do it on my own, I don't really understand, what it really is.
Okay, you didn't really quite get what it means, right?
Yeah, like I understood the objective, but just understanding the technical, like on the technical.
Okay, technical aspect, like what goes on under the hood, right?
Yeah.
Okay, do you know what bag of words is? Although this is NLP, that's why I was too slow to talk about it last week. Do you know what bag of words is?
I just took it literally like bag of words, where all the words, everything is like. So it's just a big dictionary of every word, the index of words, the index of the word. So that's how I just saw it out.
Okay, because the reason why I asked is if you know bag of words, TFIDF is more like a smarter version of bag of words. It's like an improved approach. They are quite similar, but it's just an improved approach. And this TFIDF you mentioned is a situation where you just uh sorry that's where you turn raw text into weighted word vectors. But now, before you get to the vector stage, you always have to tokenize. And during tokenization, you tend to carry out bag of words, or what's it called? Yes, bagging those words and the rest. But I still want to be slow to talk about it because NLP is something we'll still do. I think that's in the next, after this phase of topics we'll be touching on. There's a point where during the course you get to see all those things in NLP. So not to worry anyway. Not to worry. Okay. Mr. Deji, can you hear me?
Yeah, I can hear you. I also wanted to ask, like, for example, right,
Okay.
after we are already done with, like, maybe assignments given to us, after we are done, and maybe after the first, like, after the day that it has finished, like, we are meant to submit or meant to finish our assignments. I want to know which
Okay.
exact track should we be doing by ourselves. Is it machine learning science in Python, or 'cause I know from the beginning I think we were doing associate AI engineering. That was the one that we were doing for Python. Then we switched to machine learning scientists. So we are now doing courses for machine learning scientists, right? The one that they are assigning to us. So I really want to know what the focus
Oh,
is for
wait.
me.
You said
Like
you were doing you said you guys were on associate AI
associate
engineer track.
engineer for Python. Yes, that was the one that we were doing. That was I think associate
Are you
AI,
are you
yeah, for Python.
mm,
Yes,
mm,
when we first did supervised and unsupervised, like that was the one that it was assigning courses. So now we have switched to machine learning scientists. So in a case where, okay, if we are just doing on our own, just so we can maybe be ahead or maybe learn, like understand
mhm,
some other things, we want to
mm.
focus on machine learning scientists
Okay,
because I
see,
was trying
just
to.
follow. Okay, go on. If you're not done, go on.
Oh, no, I'm done. I was just saying that I was trying to
Okay.
do a course after
Mm.
the one,
All
but I
right, I
don't know
get
which
it.
one to.
So okay, yeah. So I that supervised and non-supervised learning, you're saying that falls under associate AI as well, right?
No, no, both of them has it, right? Machine learning, but from the beginning, my initial objective that, okay, it was assist AI that we're doing for us because I think the first three courses, it was under assist AI. So I thought we were following that. So now we have
Mm,
the course that comes next, associate
mm.
for that assist AI. We've not done it for like some months now. Like it has not been assigned to us for some months. But
Okay.
for machine learning scientists, right, they have been assigning courses under that one. So I want to know if you want to do it on our own right now, maybe we want to just follow so that we can be fast. You should focus on it. Machine science, as I said, AI.
Mm. Okay. So let me answer the question one by one. Actually, we had this thought because we are even facing similar situation. Yeah, fine. Some people hope to do. They want to do. What's it called? They have in mind to be a machine learning engineer or maybe an AI engineer, for instance, or scientist. No, AI engineer. There's nothing like AI scientist. Yeah, they're scientists. Those won't carry out research in AI. So whatever the case may be, whether machine learning or AI, yes, there are steps towards this approach. So that's why we took a step backward. But I'll still have to discuss with Mr. Dixon because he's our team lead and maybe get his thought process on what happened during the time because I'm not quite aware of that interaction you guys had with Associate AI track. But we have to do take it up from the basic. Although machine learning is not the basic towards AI, it's in fact it's even data analysis before you become your data science, before you get to touch machine learning, before you get to do AI because each each is like a building block. They're built on each other. So what I will tell you is doing machine learning first before going into AI is the way to go. So if we have the time and we are done with all these machine learning courses, these machine learning scientists and engineers, well, we'll definitely move into AI. So for the next, if it tends not to, if we can't complete this by the end of this cohort, I believe for the next cohort there will be a what's it called like a breakout session specifically for AI engineers. Now this will be from people who are done with machine learning, scientists and engineer, and you tend now to you're now doing the what's it called? You've moved on to doing AI engineering. That's if AI is your end goal because some people just stick to machine learning and say, okay, I just want to remain a machine learning scientist, depending on what you love. Yeah, so that's it. Then secondly, if you follow the courses sequentially on machine learning scientist track you are now, if you're done with what's it called XGBoost, for instance, now the next course that follows, do it. Don't wait for course assignment. Okay, don't wait to be assigned that particular next step or whatever this will be given to you. So just go like that sequentially. You understand, so that you can be ahead of time. And whenever we have sessions like this, maybe you're done with XGBoost, now you can tend to have definite questions, more how do I put it? Questions that tend to improve your understanding. You see that things become more brighter for you in terms of understanding. So that's it. I hope I understand. I you understand my explanation and I've answered all your questions, Mr. Deji.
Oh, yes, yes, yes. But one more thing, I don't know. Is it realistic that we would that is it realistic for someone to maybe try to learn machine learning and AI at the same time? Because maybe you want to
At the same
keep
time.
learning and yeah, just
Okay,
like a
no, no, no,
personal
no, no.
advice. Like
No. A personal advice, take it from someone who has attempted this in the past. Don't do that. Don't do that because AI has this. It has this wholly different concept. Like the concept explained in AI, though is built on things in machine learning, but if you've not gotten the fundamentals of machine learning, I don't advise you move on. I don't advise. Sorry, guys, I'm a bit sidetracked. Sorry about that. All right. So, Mr. Deji, I don't advise you do that. So, first of all, get the machine learning fundamentals, finish this course, and you can go on to do what's it called AI, and you'll be glad and you appreciate yourself that you did so. Because if you just jump to AI, my brother, I tell you, like someone who have been through this before, you will just I mean, you might just be lost in the dark because, in fact, there are concepts that will be mentioned in AI that will still take you back to check on those machine learning fundamentals. It's like you'll be redirected. Once you maybe you're reading on what concept should I use now? LLMs, for instance. You're talking on you're learning LLMs and you come across tokenization. My brother, that's a red card. That red card means, my brother, go back to machine learning and learn tokenization because that's one of those things you learn during natural language processing in machine learning. So I believe that answers your question.
Oh yes, it does. Thank you very much. Thank you. I really appreciate it.
Okay. All right. All right. So, Tato, please, what's your question?
Oh, evening, sir.
Yeah, good evening, sir.
Sir, I was late on my previous two assignments, so I wanted to ask if it will have
Yeah.
an effect on the previous assignments now.
Okay, you didn't do the previous assignments.
I was late, sir.
Okay. Oh, late. I don't think that's counted though. If you're late here, I don't believe it's counted. But what I advise is, then please just try try to always be on point with your assignments. And let me give you a productivity hack, and I believe this should work for everyone. Now, Tato, are you with me?
Yes, sir.
Okay. When you are assigned an assignment, is it like a week span before you get to submit? Is the deadline within a week? Like within 7 days? Is it 5 days? Is it 3 days? How long is it?
It's within a week, sir. Just that I lost my laptop because of like
Oh,
where I stay crime.
oh. Sorry about that. So I hope you have a new laptop now.
Yes, sir. That's how I made the session.
Okay. Sorry to hear that.
No problem,
That's
sir.
yeah, that's unfortunate. Um. Okay. I don't know. I don't really know how we can do for that backdrop because that's an unfortunate event. It's unplanned. Okay, you know what? Run this through Mr. Dixon. Okay, just go on Discord and tag him. Okay, so just tag him on Discord and run it through him. He's the team lead, so he's the one that normally does the assignment. Yes, I assign the assignment to everyone. So I believe he should be able to come up with how we can do this. Okay.
Okay, thank you, sir.
All right. To Hikma, what do you have for us?
Good evening, sir.
Yeah. Good evening,
Um,
Hikma.
sorry, when you answered my question about the attendance at first, I did not get you. My
Mm.
network was not that good at that moment. Hello, sir.
Okay. Did you ask a question? Did you ask a question about attendance? I can't remember myself.
No, yes, I said I sent you a message on Discord and you said you were going to check. I did not get your response.
Okay. Okay. Yes. Um. Okay. For last week attendance, right?
Yes, sir.
Yeah. Hold on, please.
Okay, sir.
All right. Sorry about that, Hikma. Um. All right. Have you been able to fill the one for today?
Yes, I have done that, sir.
Okay. You know what? While on the call, let me just execute. Let me execute that. Let me run that through Daya. Daya should be able to handle that. Hi, Daya. Please. um, Student. So don't worry, I'm handling it now, Hikma. Don't worry about it, okay?
Thank you, sir. Also, sir, please, I wanted to confirm something about that data camp assignment.
Okay, what's it?
I noticed that when we are assigned a course and it says the deadline is like on
Mm,
25th, because
mm,
last time we were assigned an assignment, I finished one course, the other course, I had some interviews and exams. So I was like, okay,
mm,
I'll finish it on that 25th before 12 p.m. But when I woke up in the morning of that 25th, I noticed that it's already saying I've missed the assignment. So I want to understand, is it that the assignment, if it says 25th, is going to end on 24th by 11:59 p.m. or the next
mm.
on that 25th by 11:59 p.m.?
Yes. I think it has to be before the set date. In fact, what I'll tell you is I just try to always do the assignment even before the last day. I mean, it's like 7 days we have within that day. Like if you have 7 days, try to do it within 4 or 5 days. Just Because sometimes these assignments it doesn't take long. With the appropriate research and revision, you can just get the assignment out of the way instead of maybe holding on. I know we have other things we do with our time, other busy times, but 6 days, within 6 days at least we should have at least an hour or two. Yeah, we can have an hour or two where we can just dedicate for the assignment and get it out of the way. So please don't always wait for the last day or before the last day to get it done. Okay, Hikma?
Yes, understood, sir.
Yes, yes. Is this your
Thank
your
you.
correct full name? Hikma Yahya.
Yes, Hikma Yahya. Yes, sir.
Yahya. All right, thank you. I like the
Thank
pronunciation.
thank you, sir.
All right. Mr. Samuel, I don't know if he's still on the call. You were raising your hand. He's not even here. Okay. I think that's all the okay, Akachi. Okay, Akachi, please go on. Ah, Akachi, yeah, you mentioned this earlier. Uh okay. But please, let's try our best to always sign the attendance before we leave. I know this was an accident, but please always try to sign the attendance because some other cases there won't be this chance or grace to get us through the back door. In fact, this will be the last time. This will be the last time I will get anyone through the back door unless it's quite a different situation entirely. But if you're on the call, please just try your best to always stay to the end of the call. All right, no problem, Makachi. I'll get it handled for you. Okay. All right. Any other question? Anyone? So we can call it today. Okay, no question. Good night, everyone. Have a good Sunday ahead and a good week. All right. Bye bye. Yeah. Bye, everyone.